Hi, this video is just to explain the last part of the Element Builder Lab because it seemed like some of you were struggling with how to do the dot diagram part. So if you haven't watched the first video of me explaining how to do Gizmo, go ahead and watch that if you need help. This is just going to be looking at the last part. So activity B, where we're looking at the electron arrangements, we went over that. And so I just want to emphasize that some of you have been putting the total number of electrons around each element, but valence electrons are just how many are on that outer ring. So if we put in, we change this to like carbon, which has 6 protons. So I'm going to go ahead and add 6 neutrons and 6 electrons. When in doubt, just give them all the same number. That's usually their stable isotope. But you'll notice that carbon has 6 electrons, but only 4 are considered valence electrons because only 4 are on the outside. 2 are going to fill up the inner orbit, and the other 4 are going to go in the outer orbit. So when we do an electron dot diagram, which you can see by checking this box, it shows you not how many electrons are in carbon, but it shows you how many valence electrons are in carbon, how many are on that outer orbit, and those electrons determine what carbon is trying to bond with. Because remember, carbon likes to have all elements like to have a full orbit. So ideally, this second orbit fills up at 8 electrons. So you can fill up to 8 there. And so carbon only has 4. So you can see that carbon is ready to bond with lots of things. So right here for this one, valence electrons, if we create lithium, which is 3 protons, let's go ahead and give it 3 neutrons and 3 electrons. Okay, there are 3 electrons, but the number of valence electrons is going to be 1. Okay, so that's right there. And then it says draw the electron dot diagram for lithium. So this is the electron dot diagram. So I might go ahead and hopefully you've figured out CAMI, but lithium, I'm going to just go Li, and then I'm just going to make a dot there. Okay, like that. That's not great, but it shows me that I've got 1 valence electron. Okay, and then you're going to be practicing. It says turn off, show the electron dot diagram. Okay, so I'll turn that off. And then you're going to use it to create a neutral atom of each of the following and try to draw the electron dot diagram. So hydrogen, it's going to start with number 1. So we'll just go back to number 1. Okay, hydrogen, and we'll keep everything neutral. So we're going to have similar neutrons and electrons. So hydrogen has 1 electron. That's pretty easy. I don't need to see the electron dot diagram, but if I'm not sure, I could take a little peek at it and be like, yep, I knew that. So you're going to go ahead and do 1 dot here. Okay. Helium, on the other hand, okay, helium, I'm going to add another proton, and I'm going to make it neutral. So I've got to have 2 protons, 2 electrons. And now I know it's got 2 electrons in its outer orbit. So here is helium. Okay, I already knew that, so so it's saying to try to guess it and then double check your answer. Okay, we already did lithium, we already saw that. Let's jump to fluorine, but these all go in order, 1, 2, 3, 4, 5, 6, 7, 8, 9. So but I'll jump up to fluorine. Okay, so fluorine has 9 protons, so I'm going to go ahead and give it 9. The neutrons don't really matter. Okay, so 9. Okay, so I can see that 2 are here, and 9 minus 2 is going to be 7. So there's 7 here. So I need to put 7 on this outside. Okay, so this is a little tricky. I'm going to put a colon here, then I'll put a colon here, and then I can scoot this a little closer if I want. Okay. And then I need to put 2 periods here. Okay, and then I need to put 1 period up here. Okay. So do you see that? That was sort of. So I've got 7 dots around fluorine. If you find it easier to just print this out or write it on another paper and draw the dots in, that's fine. Okay, so this is how, and then if I check fluorine, that's correct. I've got 2, 2, 2, and 1. It doesn't matter where that 1 is. Okay, so then it talks about how chemical properties are determined by the number of valence electrons, valence being just the outer electrons. So which element has similar properties to lithium? Okay, so I want to look at lithium, and I'm going to look hopefully back from up here. I'm going to look at lithium, and I'm going to look at which of my other ones have the same number of valence electrons as lithium. Okay, so by now you should have done all of these, and lithium, I know, has 1 valence electron. So I want to see which other elements have 1 valence electron, and I'm going to write that there. Beryllium has 2 valence electrons because there's 2 on this outer orbit. So I'm going to look and see of the other ones I did, which one also has 2 valence electrons. Okay, and then I'm going to explain why I put them together, and you're going to say that they had similar valence electrons. Okay, now you're going to see that these elements that you just did up here are actually arranged in a certain order. So hydrogen goes here, helium goes here, helium doesn't go here, but it goes over here. And then the other elements follow in these rows. Okay, so they kind of follow in these rows, and then they also line up in these columns. So the first question is, why do you think they're arranged this way? It says if you have another here periodic table, you can take a look, and I did post a link of one, so you can see this right here. Okay, and these are all the periodic table, and okay, so you can sort of take a guess why you think they're arranged this way, and then you're supposed to do the dot diagrams again, but you've done them up here, but this time they're in this order, so you'll be able to see what the pattern is, okay? And so you're going to look at the columns. What do each of these columns have in common? What do the elements in each column have in common? Okay, and it has something to do with their valence electrons. And then you can talk about how it's organized. So that's how this ends. Again, you're going to draw in these dots. I wonder if you can just copy and paste things. But that is the point, that all of these elements are listed in a particular order because they have things in common. This family, okay, they all are super reactive, and they all have certain properties that are similar. Okay, they're different elements, but they sort of act similar in many ways, or they look similar. This one also, these are called the noble gases. These are not reactive and has something to do with their outer orbit, that it's completely full. And so they don't need to bond with anything. They're just like completely stable, content the way they are. They're not looking to bond with any other atoms. So these are considered super stable. But you can see that's why they're in the arrangement that they're in. If you do the Google Doc version, I had trouble drawing the dots in, and it says to kind of use a drawing tool. This one, if I click on it, I don't see like a drawing tool edit. This one, I know someone did it. I saw it, but I'm not that savvy. Here, if you go here and you do edit, then it takes you to this drawing tool. And honestly, I was having trouble. So you could make it bigger, and then you're supposed to like draw those dots in. So I don't know. I think someone did circles, okay, and they just made them really small. They kind of try to put them in. So hydrogen has one, and they did this kind of thing. But if you start getting super frazzled by that, just draw it on a piece of paper and take a picture and attach it. Okay, so hopefully that helps. And if you have any other questions, feel free to ask me.